Okay, so we're now going to look at the volume solver together. There is a sample in here already, which I can load. And you can see in the sample there's like two pads. I'll just exaggerate the Z scale here a little bit. So there's two pads there. You can switch off the existing ground just to see, and then there's a bit of a pond, and then there's a cross section cutting through this section here. There's a platform here, and then the platform drops down. You've got finished grade level, and then the subtraction of the building depth. So if I change that to 0 for the building slab, that should move up. I'll do the same for the car park, which is a 300mm layer, that goes there as well. And so now the comparison is just the sample ground surface and existing ground surface. And then you can see this kind of blue area is what's been calculated, or brown area. Typically we don't calculate from that, so we'd have to subtract down maybe topsoil 150 mil, say. That brings that down, and that's gone up. There's a negative value on there. And that's how that is. But what I want to show you instead of the kind of sample that's loaded is the grading solver. We have this surface in here, which is the sample from here. It's just a bit smaller and it's probably more useful. This also, you can see, has the sample or section line cutting through the grade of the ground. This is kind of a car park that comes through here and then drops down. It's not fully graded with retaining walls yet, but for our purpose, it's probably good enough. So what we would do here is we would export this as LandXML, and you can see that's gone up there. And then we would just drop that into the volume solver. So I'll do that now. Into the volume solver. Okay, we can see this now. So you have three surfaces in here. You have, it says EG stripped. Yeah, because EG you should already have, which is existing ground. And that's fine for what we want it now. We'll just close that. We've also got the finished surface, which we can look at it, but you can kind of get a sense of, there's the building platform, the car park, little entrance coming through there, and then some daylights to the existing ground. As I said, that later on we would develop retaining walls. For the sake of this exercise, it's good enough. So what we typically do a comparison between is the EG strip surface and the finish grade minus the building platform levels and the layer works maybe for a car park. So that would give us these values here, which should be around the same as the grading solver. There's a slight difference, but I can solve that later. But for the sake of this exercise, if I show you the difference map here, we can just go through some of the what's shown here. So we've chosen our two surfaces, so we can close that. Then there's the computation grid. We can make that tighter. You can see it should change there. The pixelation, so it's better when we come to export this. You've got the volumes, which it is what it is. You should have. It's good to look here, and you can change them by dropping things and so on. But that's something we can do in the grading solver. This is more just to make it ready for presentation. Okay, so now we come to the color bands. So the color bands, usually bulk earthworks drawing is made to give to the contractor or constructor, and they typically give some idea of kind of what the value is in terms of the depth of fill or the depth of cut. Could be more expensive. So I'm just going to split these quickly into the different categories from 1.1 to 1 meter. In Civil 3D, these tend to be manually each one, but I've matched these together to make it quicker. It's just a bit fiddly in Civil 3D. And then 0.5 to 0.1, and then 0.1 to 0 to kind of see where that cut line is. I mean, you could also just do it to, cut and fill. Just have two of these. You can just delete them if you wanted to just show it that way. But we will go 0.1, then to 0.5, and then to 1, and we'll get rid of that one. And that should give me, the quantities, as you can see there, for the different volumes. And then you've got the different colors, and you can change those colors if you wanted. Like you could take more of a green theme if you wanted here. Just to show you. Typically I like to show the the green in the kind of the deeper fill areas. So we can do that like that. And this one is also going to be green, just a lighter green. And then as it gets to this number, it's more of a neutral between the green and the red. So we can leave it yellow, and even this one yellow as well. A little bit darker yellow, something like that. So you get the idea. So that will help us identify quickly where those areas are. So when this gets exported to your DWG, your CAD file, you can see what's happening there. So that's the data, color bands done. There is draw region and there's import from DXF. So if you did want to analyze which areas there's cubic meters, so we know there's a building platform up here, you would bring in, you can either draw it manually or you can import it from DXF. So let's quickly import from DXF. Okay, there we are. So you can see region 1, 2, 3, 1 was the entire boundary, so that's the entire amount. Region 2 was this building platform up here, 350 cubes of cut. We expected that. It's all in cut. And then you've got the cut and fill. In this area is the cut, and then this is the fill here. So that's another little thing you can do, and that's typical for regions as well in Civil 3D, so it's comparable. You can actually drop these as well if you wanted. It'll drop a vertical line, so if you wanted to play around with it a little bit, but it's not really supposed to be a design tool. It's just more to kind of get an idea of what could or couldn't happen before we went back in to do that back in the grading solver. Okay, so that's ready. Now, in terms of exports, we'll go for heavy, and we'll make it as kind of as precise as possible. Keep every spec. Label spacing, you can go every type 5 meters or 10 meters, depending on how you want to show those values. Surface spacing difference, we'll do that. And then there's an orientation. So in this instance, it's pretty close to level, but if you did want to set the angle of the value so that maybe your page is set at a, not like here, north is directly north, but you want to set an angle, then you would just use the angle button here. So I can click like that, and then when the labels come in, rather than being across the page like this, they'll be across. So just for the sake of this exercise, I'm just going to try and match this angle here. I just clicked on there now. That's a section line. Try that again. So we go from there to there. All right, and so those labels will be across like that there. Yeah. And so that's ready now for export. So all we'd have to do is click export. And then when we open that in the DXF file, you will see it in CAD as it's shown here. Plus it'll have the volumes as well for the different regions or depths as well. So in CAD, this is what you get. Easy to switch off. Everything's on layers, so it's easy to switch things off. As I said, you can see now how that text for this instance was rotated if you did end up with a rotated viewport. The exact position of that depth, I believe, is on the decimal place. But that's the position of where that actually, because there's no, I haven't installed any X points yet for this. And you also get the data in kind of a tabulated form in CAD as well. You might need to explain a bit more what this means, e.g. stripped, and what subgrade is, and maybe explain to the constructor what exactly those numbers are to determine, or explain how you got that cut and fill. Yeah, difference label anchor point is the decimal point of the value. That's what that's saying, and then you've got the different bands and the depths. And that's it for the volume solver. Next one is the part solver, which it will feed into the grading solver. Please like and subscribe, and I hope you enjoyed the video.